Hello friends, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11th and class 12 topics. Now today we will discuss something about ionic equilibrium. In the previous videos of ionic equilibrium I covered up to common ion effect. Now today we will discuss buffer. If you wish to go through the previous videos, you can find the link right up here. Okay, now let's start buffer solution. Now what is the meaning of buffer? Buffer is a solution which resists in pH change upon addition of strong acid and strong base up to a significant limit. Means it is a solution, if you add strong acid or a strong base in it, so it will resist in pH change and up to a very significant limit. Are you getting the same? Let me show you, let me give you an example ki how pH changes if we add some amount of acid or base in a given solution. Okay, it's not a buffer. Let's see. Suppose we have 999 ml of pure water. So its pH will be how much? 7. Now what we have done, we have added here just 1 ml of 0.1 molar HCl. 1 ml of 0.1 molar HCl. Now what will be the final volume? Final volume will be 1000 ml. Okay. Now I'm asking you what will be the pH of this solution. So you can treat it as a question as well. Okay. Now for finding pH of this solution, I need to find the molarity of HCl. How can I find it? Let's see. Millimoles of HCl in 1 ml, millimoles of HCl in 1 ml will be equals to millimoles of HCl in 1000 ml. Okay, means whatever millimoles are here present, those same millimoles will be transferred here. And what is the formula for millimoles? Molarity into volume in ml. Let's say here molarity is capital M. So 0.1 into 1 means molarity into volume in ml must be equal to its molarity multiplied by volume in ml. From here I got molarity equals to 10 to the power minus 4. This molarity belongs to what? It belongs to HCl. So that means H plus concentration is what? 10 to the power minus 4. So what is the pH? pH is 4. Earlier pH was 7, now pH is 4. So what is delta pH? Delta pH is 3. Are you getting this thing? Means you just added 1 ml. 1 ml of what? 0.1 molar HCl. That is not very concentrated as well. And you are saying pH change from 7 to directly what? 4. So it is a significant change. So buffer, if your solution were buffer, it will not allow to happen like this. Okay. Now let's see something more about buffer. Now, before understanding the working of a buffer solution, let's understand a very basic thing. Okay. Suppose if I don't want to go from A to B, if I don't want to go from A to B, but somehow if you leave me at B, so would you like to stay at B or would it like to come back? I would like to come back. Means if a reaction doesn't want to go in forward, so what it wants, if you somehow make it reach up to forward, it will try to come backward. Are you getting this thing? For example, let's say CH3COOH. It is a strong acid or weak acid? CH3COOH is weak acid. So CH3COOH will give you CH3COO minus and H plus. Look at this reversible arrow. I made maximum arrow backward and very little arrow forward. Means reaction almost lies in backward. So if I somehow produce these two ions in separate vessel, these two ions, CH3COO minus and H plus, so would they like to combine? Yes, they will definitely like to combine. कि अगर तुम A से B नहीं जाना चाहते हो, तो if I leave you on B, would you like to come back? Definitely, you would like to come back for sure. Similarly, NH4OH, it is not a strong base. NH4OH is a weak base, so it does not dissociate. Means NH4OH has very less tendency to get converted into NH4 plus and OH minus. But if you somehow generate NH4 plus from this side, OH minus this side, and you bring them in contact, would they like to combine? Yes, they will combine very fast. And look at the arrow, maximum arrow lying in forward direction. Means these two will quickly combine to form NH4OH. Are you getting this thing? It's just like if I don't want to go at A, if you leave me on A, I will come back. Okay. One more thing you must know, the acid and base. These acid and bases are just like two villages of South Indian movies. Have you seen South Indian movies? Of course you have. There what happens, these two are quite rival to each other. Means if a person of this village and a person of this village, if they saw each other, they will kill each other. Are you getting this thing? So remember, if you ever found acid and base, they will kill each other, means they will neutralize each other. Okay. If you understand these two things, we can move forward to understand the working of buffer solution. Okay, now let's see. I'm asking you to consider a solution of CS3COO NH4. CS3COO NH4, we call it ammonium acetate. It is the salt which is formed by reaction of acetic acid and ammonium hydroxide. So it is a salt. So it will be strong electrolyte or weak? It will be strong. So it will decompose into CS3COO minus and NH4 plus. Are you getting this thing? Very well. Now suppose if you add H plus from external source. Suppose if you add H plus from external source, means you are adding strong acid. You are adding a strong acid. Now, is there anyone present in this solution who would like to interact with H plus? Yes. Who is that? CS3COO minus. I don't want to go to A. If you leave me on A, I will try to come back. Very same story. These two will combine to give you what? CS3COOH. What happened here? Your mostly H plus will be, tell me, mostly H plus will be now in dissociated form or it will be in associated form? It will be in associated form. So since it is in associated form, so is it free? Is it free to decrease the pH? No, H plus is not free. It is now in combined form. That means no significant change in pH, because pH is changed by H plus or OH minus. Now H plus is not free. Whatever H plus you added, that H plus is consumed by CS3COO minus. So no significant change in pH. So you added H plus and that is waste. Getting this thing? This is called resist in change in pH. Okay. Now, if you are a buffer, so you should resist pH change upon addition of H plus as well as OH minus. So upon addition of OH minus means strong base. Now, if you add some amount of strong base here, let's see what will happen. Is there anyone in your system who will be able to interact with OH minus? Yes. See, NH4 plus. So what will happen? This NH4 plus will combine with OH minus to give you what? NH4 OH. Means it will be maximum in forward direction, it will be maximum in backward direction. It will be in forward direction, means all the OH minus will be now in associated form. So same language which I wrote here, I will write in terms of OH minus. Let's see. Mostly OH minus will be in associated form. That means no significant change in pH. Revealing this thing. No significant change in pH. Why? Because whatever OH minus you added to increase the pH, that is consumed. Is this clear? So, can I say, is CS3COO NH4 solution is a buffer? Yes, it is a buffer. That's why it is resisting change in pH. Is this clear to us? Good. Moving forward. Now, buffer solution are of two types. One is acidic buffer and one is basic buffer. If you want to form acidic buffer, you should have a weak acid and it's salt with strong base. Similarly, in order to form basic buffer, you should have a weak base along with its salt. You're getting this thing. Okay. Generally, it is found that pH of acidic buffer is less than 7. Okay, and pH of basic buffer is greater than 7. In general, it happens. There may be few exceptions, but maximum time you will find pH of acidic buffer is less than 7 and pH of basic buffer is greater than 7. Now let's see some examples. Take a name of weak acid. Weak acid means, let's say, CS3COOH. Please pardon the background noise. Okay, CS3COOH, and let's say salt. Salt is CS3COON. Okay, let's take HCN. So its salt will be, let's say, NaCN, KCN, etc., etc. Okay. Here, let's say one more acid. Let's say formic acid, HCOOH. So what will be its buffer? Its salt. Salt will be HCOONA or HCOOK, like that. Let's take one more example. Let's say H2CO3. So H2CO3 along with what? Its salt. NaHCO3. Okay, one more example, let's see. Let's say NaHCO3 along with what? Na2CO3. You're getting the same. Means acid and its conjugate base. Acid and conjugate base. Don't worry about this Na. Na has no role in water. Na has no role in ionic equilibrium. It is just a counter cation. Every anion requires a cation. That's why Na plus comes. It is just like a person who visit a wedding just for photograph purpose. Are you getting the same? Means generally what happens in a marriage, when you see mostly people just come in order to get photograph clicked as a proof that they were present, hand to eat. That's it. So Na plus is a spectator ion. It does nothing. Okay. Now let's see here. What will be the example here? Let's say weak base. Take a name of weak base. Weak base, let's say NH4OH. What will be salt? NH4Cl. Or you can have NH4 whole twice SO4 as well. Okay, like that. Now, take one more. Let's say C6H5NH2. This is aniline. And its salt C6H5NH3 plus Cl minus. Anilinium chloride. Are you getting the same? So similarly, you can make so many examples here as well. Okay, let's say RNH2. So RNH3Cl. Okay, this thing there. Good. Moving forward. Now let's understand the working of acidic and basic buffer. So let's take an example of acidic buffer, which is weak acid and its salt. Basic buffer, weak base and its salt. Okay, now see, if I consider this solution, see, both must be present together. It's not like alone CSCCOOH is there and alone CSCCOO minus. It should be both present at a time in a same solution. That's when it will be called buffer. Okay, now what is CH3COONA? It is a salt. So it will be strong electrolyte or weak? It will be strong electrolyte. So it will give you CH3COO minus plus Na plus. Okay, now what about CH3COOH? CH3COOH is weak electrolyte. I mean, it is a weak acid, but still it will give you CH3COO minus plus H plus. Okay, now if you add some amount of H plus, please pardon the background noise, upon addition of H plus. Now, is there anyone in your system who will interact with this H plus? Yes. Who is that? CH3COO minus. So what will happen is CH3COO minus will combine with H plus to give you what? CH3COH. CH3COH. Now what about CH3COOH? CH3COOH is a strong acid or weak? It's weak acid, so it will be mostly in associated form. Now, it will be mostly in associated form, means your H plus that you added in order to change pH, now it is gone. It is gone, it is no longer available. Are you getting this? So what I will write? No change in pH significantly. It's not like a zero pH change will be there. It will be somewhat changed, but not as 2, 3 like that. Okay, so very less amount of pH will be changed, or you can say no significant change in pH will take place upon addition of what? HCl or H2SO4, whatever strong acid you are using. Okay, clear? Just like previous example. Now, suppose if you add OH minus upon addition of NaOH. NaOH means OH minus. Let me write here directly OH minus. So, is there someone in your component who will like to interact with OH minus? See, is it Na plus? Some people say, sir, Na plus can interact with OH minus. So let's see. If Na plus will interact with OH minus, what it will form? It will form NaOH. And NaOH is what? Strong electrolyte or weak? Strong. So it will again decompose into Na plus and OH minus. Ultimately, no reaction. So OH minus will not combine with Na plus. But there is someone who will like to interact with, OH minus for sure. Remember that 2 villages of South Indian movies? Yes. OH minus is what? Base. Is there any acid present in your solution? Yes. See, CS3, COOH. Can you see this thing? Yes. So OH minus, what OH minus will do? It will interact with what? H plus. Produced by whom? CS3, COOH. And ultimately means how OH minus is reacting with whom? OH minus is reacting with CS3, COOH. See like this. The OH minus will react, now see, OH minus will combine with H plus to give you what? H2O. Now let's add these two reactions because H plus is coming from this only now. So let's add these two. So what we will get? See, we will get CS3COOH plus OH minus gives us CS3COO minus plus H2O. What happened? Whatever OH minus you added, that is gone. It is no longer available. Who ate it? It is CS3COOH. So will pH change will take place? Means significant change will in pH will occur? No. Very small change in pH will occur because mostly OH minus is now consumed. It is will not available in the solution. So that's what I'm writing here. The entire OH minus will be gone or consumed. So no significant change in pH. Are you getting this thing? Okay, so this is the working of what? Acidic buffer. Now let's look at the working of basic buffer. In basic buffer, we have NH4Cl and NH4OH. So NH4Cl is what? Strong electrolyte or weak electrolyte? Strong electrolyte, so it will give you what? NH4 plus and Cl minus. What NH4OH will give you? NH4OH is a weak electrolyte, weak base, so it will give you NH4 plus and OH minus. Now let's see upon addition of H plus. Upon addition of H plus, is there someone who would like to interact with H plus? Yes. Is it Cl minus? No, don't say this, because if H plus will interact with Cl minus, you will get HCl, and HCl is a strong electrolyte, so it will again give you H plus and Cl minus. So don't say HCl minus is going to interact with H plus. Never. You just remember this thing. In ionic equilibrium, there is no role of Cl minus, Na plus, K plus, Br minus, I minus in pH deciding factor. Okay. Now, upon addition of H plus, who would like to interact with H plus? Remember, two villages, enemy of each other. It is OH minus. So H plus will react with what? OH minus. So you will get what? See, you will get water. And what is the source of OH minus? NH4OH. So ultimately, who reacted with H plus? Who reacted with H plus? It is NH4OH who reacted. So NH4OH, I am adding these two reactions and I will get NH4 plus H2O. I hope you can see whatever H plus you added, that is gone. Means all H plus gone. All H plus gone means very, let me write, no significant change in pH. No significant change in pH will occur because entire H plus is gone. Okay, now let's see. If you add OH minus, upon addition of OH minus. So if I add OH minus, so is there someone who will interact with OH minus? Yes. Who is that? NH4 plus. Or who is the major source of NH4 plus? NH4Cl. So you know what will happen? NH4 plus will interact with OH minus to give you NH4OH. And NH4OH is a strong electrolyte or weak electrolyte? It is a weak electrolyte, so it will be very less dissociated. Very less dissociated means your maximum OH minus is gone. So will huge amount of pH change take place or a small amount of pH change take place? It will be no significant delta pH, means pH change. So this is the working of buffer. This is the working of buffer. Okay. Now in this video, we discussed about what is buffer and how buffer actually works. Okay. In the upcoming videos, we will discuss some problem based upon buffer solution. Okay. So your task will be to make the proper note of this buffer solution and understand and go through the working of buffer one more time, think you how it happened. If you got any doubt in this topic, you can ask me in the comment section. Till then, take care and keep studying.